Hi everyone, welcome to another of our RavenDB webinars. And this one is actually a fairly interesting one. We're going to talk about scaling and sharding with RavenDB. When we're talking about scaling, we're talking about the ability to add more resources into a system and gain the appropriate increase in the overall system performance, or the not performance, in the overall ability of the system to actually process more requests. So let's talk about the options that we have. In general, it means that maybe we have more data to work with. Previously we had, 50,000 documents. Now we have 500,000 documents. Maybe we used to have 50 users, now we have 5,000 users. So the question here, when we need to get to those points, how do we actually handle the increased demand? And RavenDB actually have a very simple scenario for that. Obviously, we can use the scale up scenario. So if you give us better hardware, we will be able to process more requests, be faster, and all of that. But for the most part, when we're talking about scaling, the scaling strategy, we're talking about scaling out, having more machines. And we're talking about scaling out scenarios. Even so, we have two alternatives. The first alternative is to talk about the single dataset. In the single dataset scenario, we have multiple machines, and every machine has the entire dataset that we are working at. This is commonly, usually we talk about replication, master, slave, and we discuss all of those options with regard to replication in a few minutes. The second option is sharded dataset. Sharded dataset basically means that we have multiple multiple machines, and every machine has some part of the data. The benefit that we have here is that we're able to split the load between multiple servers, and the size and the number of requests that each server has to deal with is those become much less important. And obviously we have something that related to mix. For example, if we have some data that we want to replicate to all the nodes and some data that we want to split among the nodes, but this is far more a scenario, and we'll touch this later on. The first thing that I want to talk about is replication. So I think almost from day one, RavenDB came with replication support. And we use replication mostly for failover. So I want to introduce a new tool. It's called the Raven Visual Host. And please don't look at the code base for this one. It's ugly and disgusting, but it does one thing. It allows me to run multiple RavenDB servers very easily, and it allows me to set up a replication between them, again, very easily. So what I've done right now is set up replication between 4 RavenDB nodes. Let's look at them. So now we can see that I have 4 RavenDB servers. And so far they look identical. Note that I set them up with the following configuration. So this is node 8076, and it is set to replicate to the following 3 nodes. If I will go to this node, which is node 8078, and I go and look at the replication strategy here, it's set to replicate to the other 3 nodes. So, oopsie, one second, I forgot one thing about the configuration. I need to set up the replication bundle again. Okay. Yeah. So again. So with that, I just need to set up something here. I need to make sure that the replication bundle is actually installed for this team. Now I'm going to create a document, call it user/Allende. And I'm going to save. The moment I saved, something very, oh, look at this. I saved, but I saved it on 8078, and now it's on 8077. I'm now on 8076, and if I'm going here, I can see it here as well. I open, this is Rayan. Let's change it to Orenani, and go here and open that. Oh, oops. And you can see that it was updated for us in different nodes. Coming back to the visual host, you can actually see how this happened. You can see the state of the request. One second. Here all of the replication requests between the different nodes. And it's fairly interesting and fairly obvious to see what's going on. So far, this isn't nothing new. I assume that if you have been following RavenDB for a while, you already know about that. Again, I'm going to restart all of the servers. I'm going to set up master-master replication between them. And now I'm going to do something very interesting. I'm going to go into this case. And I'm going to create a new user. Notice that in this case, we're going to create a new user against port 8079. And now what we want to do instead, so we're waiting, and session dot so this seems to be a very simple scenario. We are saving the user, then we are waiting, and then we are reading back the user. Let's see how it works. Now we are waiting, and we can see that, again, we are now on the first one, on port 8079, and as you can see, this match port 8079. We have put this user. I'm going to clear all of the log. Now I'm going to kill this server. What this means is if I'm going to go here, you see it's not found. I cannot get anything here. That is because the server has been killed. But what would happen if I hit enter now? If we go and look at the code, you can see that we are going to open a new session and try to load the user that we have previously saved. Now you can see it's wait a while, and then it actually goes ahead and gives me the right value. How was it able to give me the right value? You can actually see here that it went ahead and went to the secondary server. How did it happen? Well, when we load the server, one of the things that we're actually going to do is to look at the Raven, when we start the client, we look at Raven/replication/destination. And this thing tells us what are the destination that this node replicate to. And by default, if the main server is down, then we are going to try to look at the other servers to see if they have something for us. And in this case, we killed this node. So the client has automatically failed over to the secondary one. In this case, it was 8078, as you can see here. So this is actually using RavenDB replication in a very simple scenario. In this scenario, the only thing that we are using RavenDB for is to actually failover as a hot standby. Another thing that we commonly see people using RavenDB replication for, is to actually do geolocation. So in these scenarios, we actually have two servers, let's say, or more servers. Let's say that we have one server in London and one server in Chicago. And they are set up to do master-master replication between them. This obviously means that we also have a data center in London, data center in Chicago. The nodes that are the clients that are in the London data center are set up to look at the London database as the main one. And the clients in the Chicago data center are set up to look at the Chicago database as the main one. So each of them is actually using the local database for reads and writes. And RavenDB itself is the one that is responsible for actually doing the replication between the two nodes. MSNBC.com is actually using a very similar scenario to actually handle both replication between data center and also a failover between data centers. If you have one node in the data center that is failing, then it will go to the secondary RavenDB or the tertiary RavenDB node inside the data center. And if all of the nodes inside the data center have failed, then it will replicate to then it will fail over to another data center seamlessly. But this is still means that all of the data is in a single server. And that is, so we have all of the data in a single server, that's perfect. But we also have another option with RavenDB. And that option with RavenDB is something much more interesting. And the reason it's much more interesting because we now have this option. And this option is read from all servers. So let's see what this does. Again, I'm going to go here, start 4 new servers, set up master-master replication, and then clear things. Let's see how this works. We created one server, one user. You can see here that we created it here, and then we have some activity among the nodes to make sure that everyone is up to date with the new stuff. I'm going to clear that. And now I'm going to hit enter. The interesting bit is here. You see this one? We're going to read the user/end document 12 times. We've done that. And let's see what we've actually done. You can see that we read it from here 3 times, read it from here 3 times, and so on and so forth. So because we have specified read from all servers, what we've actually done is to do read striping. When we are doing reads, we are actually going to go to any of those servers, and by doing that, we're able to reduce the load. The secondary servers are now not just there for fun or for hot backup. They can actually be used during standard operations. And again, this is actually a feature that was very recently added. I think it was added on Sunday. And this came out of our discussion with the developer from MSNBC, because this is actually the scenario that they are using. They have one write server, and then they have multiple servers that are running a master-master replication, and they want to designate one of them as the write server. So we've basically taken that requirement in, and now this is actually part of and this is now part of the core RavenDB feature set. And we have a question from Hassan Mirza. I think this is the proper pronunciation of the name. Can you have 3 nodes, 2 master failover, and 1 just simple replication? And the answer is that you could do something like that. You can mark, let me see if I remember correctly. You can have something like that. I don't recall the actual configuration required for that, but you can. I think that you need to specify the URL in the connection string instead of the URL. In that case, it's not exposed to client, and it wouldn't be available to the client to be used as a configuration for that. But yeah, that is absolutely something that you can do. So this is the replication setup of RavenDB. As I said, it allows us to do transparent failover. It allows us to do a nice geolocation. So we have multiple locations. RavenDB does async replication between those locations, and and the RavenDB clients are only going to touch the database that is in their own data center. So we have very fast requests. And finally, we have the notion of doing read striping, which should also help us manage when we go to very high number of requests against the server. When we're doing read striping, it's important to understand only reads are being striped. As you can see from here, this is read from all server. This is not write to all server. And the reason for that is that we want to avoid scenarios where you may write to one server and then immediately write to another server, and then you may run into conflicts. So under this scenario, writes always go to the same server. And in this scenario, it also means that we are usually talking about all of the servers have all of the data. We'll discuss later how we can do the mix and match, and this relates to having multiple databases in RavenDB, but that can wait for now. Do we have any questions about RavenDB replication? Does replication replicate existing document? You know what? I don't know. Let's find out. So right now I have 4 nodes, and I haven't set up the replication between them. So let's see what I'm going to do. I'm going to go here, and you can see that now I have replication, but we don't replicate to anywhere. So this is basically replication disabled. Now I'm going to go here, user/oren. Okay, so far so good. And you can see that we don't have, so we have this document here, and we don't have this document here. Now we are going to go here and set up master-master replication. And you can see that now we have the new document. So yes, it absolutely works for existing documents. The one thing that you have to be careful about is to make sure that the replication bundle is there from the time that you start the database. Because you can see here that replication bundle adds some metadata to the documents. And this metadata is very important when we need to do things like resolving conflict and knowing where this document came from. And let's see. You can see that now we have this metadata, and now we have the history for that. This history means that when we come here, we can see, oh, we already have this, but we can compare the history and say, yes, no, it's okay. Now, Paul is asking, what about replicating indexes? So indexes are not being replicated. That's important. If you want to replicate indexes, you have to create them yourself in each of the actual endpoints. The reason for that is that it's very common to have a replication endpoint that is just there to serve as a hot backup. Usually you do that because, oh, I'm doing that so I have different set of indexes on that end. For example, maybe I have a very expensive set of indexes and I don't want to do it on the master server, so I'm doing it over there. When we're talking about sharding, we're talking about splitting the data across multiple servers. Unlike replication, where all of the data is in all of the servers, now every server contains only some part of the data. And RavenDB actually has some really, really cool stuff related to that. Me, Itamar, and Fitzrak have worked really, really hard to make this a really awesome scenario for you. So let me show you what we have done. Right now, we're going to do the following. 0. Let's see if I can figure out how to, yeah. So, now we're going to create 3 servers. And we're going to move to the shard client sample. And in this case, we have 2 things. We have a company and we have an invoice that belongs to a company. It's very simple to understand, I think. And yeah, sorry. So let's look at what we're doing here. You can see that I define a dictionary of all of the shards. The key for the dictionary is the shard ID, and the value is the document store pointing to one of to a server, particular server. After that, I create a shard strategy, and then using the shard strategy, I create a sharded document store. Those are the 3 steps required to enable sharding in RavenDB. Once I have done that, I can do everything that I want, just as if I was using non-sharded store. In this case, you can see that we're actually going to do something fairly interesting. We're going to create 4 companies, and we're going to create 4 invoices. And you can see that 2 of those invoices were created yesterday, and 2 of those invoices were created today. And we have 4 companies: Asia, Africa, America, and Asia. Now we're going to just run this code, and let's see what's happened. So it's go away and save these 8 entities. Let's see how it does that. First, you can see that we have 3 servers, and each of them got 1 request. So on the 4th server, we saved 1/company/3 and 1/invoices/2. So usually in RavenDB, when we're talking about IDs, we'll talk about company/1, company/3, stuff like that. When we're using sharding, the default convention is to prefix the ID of the document with the ID of the shard. This means that this allows us to do all sorts of really interesting optimizations, which I will discuss at a later point in time. Okay, but you can see that we have this one, and you can see something really, really interesting. This invoice is here, but this belongs to a company that is on another server. You can see that this is on 2/companies1, and this one is in here. So what actually happened is that we were able to spread all of the documents across all of the servers, but we are doing that in a very stupid fashion. Because right now, if I wanted to go here, you know what, let's do that. I'm going to go here, query/id, and include company ID. We don't get anything. We don't get anything because this document does not exist in this server. This document exists in this server. And include cannot work across multiple databases, multiple servers. So this mode is called blind sharding. It's a fairly stupid mode of working. But let's continue with this approach for a while, okay? What I want to do now, I want to try to do this. I want to try to load a document. First, let's see that if we go here, you can see that we have this in port in the server that run on port 8078. Now we're just going to run this. And let's see how it works. So you see it went and got things. And you see that it only went to the appropriate server. Because we know that, because we prefix the server ID with the server ID into the document, we are now able to optimize things and only request to the server where we know that value can be. So now let's try to do it again, but this time, instead of doing that with a load, let's try to do it with a query. And in this case, what do you think is going to happen? First, we're able to make the query work. But notice that we had to query all 3 servers. And you can see that in here it found something, but here it didn't. There were no results. Same as here. Because we're using blind sharding, RavenDB has no way of actually knowing where the data is. This is a really, blind sharding is mostly meant to get you started, to show you that sharding is really easy. But I don't actually recommend doing blind sharding for production. The way that we actually want to go about doing sharding for production is actually telling RavenDB how we want to shard our data. So let's start everything from scratch. And let's try to do something more interesting. Right now, we want to have some way of actually sharding the data. And let's say that I'm going to dedicate it like this. So now we have 3 shards, and they are appropriately named. And now I'm going to tell RavenDB, look, I want you to shard company based on the region. And let's see what's going to happen now. I'm running the code, and I'm getting this really interesting error. We didn't set up the sharding for invoice, but other stuff has been set up. Basically, RavenDB says, okay, once you have told me that something is sharded, everything, how to shard on some entity, you have to tell me how to shard on all the entities. Because otherwise, it's going to be a really big mess. So now we're going to say, okay, how are we going to shard on invoice? Anyone want to tell me how am I going to shard on invoice? Here is how an invoice looks like. Okay, so Jeff is suggesting that we are going to shard that based on the company ID. Okay, sounds like a good suggestion. Let's see how it works. And yeah, so no request in here. And let's see, it goes away and do something. And as before, we have split the data in into the three servers. And let's look at it like that. So we have Paul and Andreas that are suggesting that you want to shard based on the company region. But notice what we actually have in here. We don't have the company. We only have the company ID. Because in RavenDB, references to other aggregates are just their ID. They are not the instance of that reference. So we don't actually, when we are going to shard on invoice, we can only rely on the data that is in the actual invoice. And company ID is in the actual invoice, so that's what we're going to use. So let's see what we have done. We can see that now we are on 8079, which is the ASEAN server. And here is, okay, so we see that this is the company one which is in Asia. And we can see that if we put it in actually the Asia server, which makes sense. But we can also see something much more interesting. Here is another company that is in Asia, company 4, before it went to some other server. I think it was on the second server. But now it's actually sitting in the same server as company 1. Because both of them share the same region, and that's what we are going to shard on. Even more important, look at the actual invoices. Both the invoices for the company 33 and company 36 are actually in this shard. So we actually have really good locality of reference. What this means is that I can go in here and say something like ASA/companies/invoices/33. What it was? 30. It was 34. You can see that. And now I'm going to do include equal company ID. And I actually get the value. And this is in a sharded environment, so include still work. How cool is that? Even if I say so myself, I think that is really, really cool. Because maintaining good locality of reference is hugely important. We don't have to do distributed transactions if we want to modify the customer and its invoices. We can just do standard RavenDB transactions, which are far, far cheaper. Let's look at some of the other servers. In here, you can see that this is an American company and the American company invoice. And again, in here, you can see that we have an African company and African company invoice. Okay? So let's see some other stuff. And this is one of the reasons I think that this is such an awesome feature. So this is for save. But let's talk about actually doing what we've done before. So, and I think that the company ID that we're talking about is 33. So right now I'm going to query for a company in Asia. And again, you can see that we query only the ASEAN server, and we got the right result. But we have already seen that before. Let's see something more interesting. Let's see what happens when we do queries. Now I want to query for invoices where the company ID is ASIA/company/34, not 33. Now, before, when we did a query, we had to go into, we have to query all the servers because we are doing blind sharding. Now we are doing a smart sharding, data-driven sharding, and let's see what's going to happen. So right now we made one query, and you can see that we only query this server. We didn't query the other two. That is because RavenDB is actually smart enough to figure out, wait, you're sharding by the company ID. So the only place this could be is in the ASIAN server. Let's see something more interesting. Let me just go drop over here and clear. So now what I'm actually asking now is show me all of the invoices that were issued today. And I'm not asking that limited to some region. What is RavenDB going to do now? We have that in multiple servers. So let's look at that. We actually got the reply that we have two shards, two invoices, and that is a request across all the shards. How did RavenDB do that? Well, you can see that we query it in here, and you can see that we get one result back. And now you can see that on the second server, there are no results. And on the final server, there is also one result. So what we've actually done is we queried all the servers, and then we merge all of that together. And that is when we have a query that we can't actually optimize. But what happened when we allow ourselves to do something that actually does work? So let's see that the one thing from today, from Africa, what was that number? What would happen now? So our querying on an item that is we are sharding on, and one that we aren't sharding on. So now we get only one of them. And now you can see that RavenDB actually made a query in here, but it didn't make a query in here. It was smart enough to figure out, oh, I know about that. The merge of, so we have a question from Paul about how did we do the merge between the shards? Did it happen on the server side or on the client side? And the answer to that is that the merge happened in the client side. And the reason for that is that this allows us much more flexibility. This allows much more flexibility in how to handle that. In fact, like all convention in RavenDB, we allow you to actually override how this works. And let me show you something that is even cooler. Look at this query. I want something from today, from this company or that company. Not that they are sitting on different shards. So that's going to actually be a very interesting query to do. Let's look at that. Okay, so we have one result, probably because I didn't get the right, yeah, it should be ASIA. Let me just go here and clear. Let's do it like that. Now we get, what? 1 second, let me just see the docs. And this is for today. So this is for company 36. Now we get 2 results, but let's see how this works. Again, you can see that we query it on this shard and we query that on this shard, but we didn't query on this shard. We already know that this cannot be in here. But notice that we didn't modify the query. So the company ID is Africa in here, even though this is for an Asia only. The reason for that is that we're being fairly conservative in what we're doing. We're not trying to actually analyze the query. We just look for those specific things, and based on that, we can route the query to the appropriate location. Now, we have a question from Chris about how does it know that invoice company ID is a document identifier for company to be able to shard on it. And I will ask you the same. When you look at that, where do you think this is going to sit? And the basic answer is that, again, we use conventions. The convention basically says, if you give us something that looks like an ID of a company, we're going to treat it as an ID. In this case, this looks like an ID. Because we know that the convention is to prefix the ID with the document ID with the shard ID, we can utilize that when we actually need to optimize the queries. This is how we're also able to get really good locality of reference and put all of the invoices for a particular company in the same shard as that company data. So we have a question from Troy. In order to prevent a single point of failure, can you replicate each sharded server? Meaning, can you replicate each of the shard with 3 total replicated servers? So we have 3 Asia shard, 3 America shard, and so on and so forth. And the answer is that yes, you can absolutely use both replication and sharding at the same time. This is actually a common scenario when you're talking about that, because if you got to the point where you actually want to use sharding, you probably really care about a failover. And something like that is really, really common. So this is absolutely something that we do. Those are orthogonal concerns, and they can absolutely work together. Just to give you some ideas, this is the shard strategy. And this allows us to do all sorts of really crazy things. Among them, it allows you to play with the conventions of how to do the sort of things. And there's a whole sort of code in here. And here you can say, you know, let's do something more interesting. Let's say I want 1, 2, and 3. This is my server's name, man. This is my server name's name. But I still want to shard by region. So in order to do that, I also have the ability to do this, to have a translator function from a, and now I can do some sort of thing between them. So in this case, I'm going to do something like get hashcode 3. Yeah. And this has to return a string. So like this. What this basically means, shard is not based on some meaningless, not based on some meaningful information, just sharded based on something. this case the region. Then we just do some figuring out on how to do that. And let's see how this works now. We're going to restart all of the shards. And let's see what happened. You can see that we are back to using numeric IDs as the shards. And you can also see that now we have company 1, company 2. Interesting. Something interesting because Africa and America apparently use the same shard ID. So this server was actually never used. But we still get good locality of reference. You see that both this and this are on the same server. And so, as well as this. And here all of the ASEAN company on this server. So using this method doesn't mean that we have fairness, and that's one of the reasons that we actually want to do sharding. And so we don't want to do something like that because it's not fair. Because you can actually have, based on the actual data that you have two nodes that are very busy and one node that is just sitting there doing nothing. And we have a note from Simon, I think. I'm sorry if I'm killing your name. You should not do sharding on get hashcode. Its implementation can and did change. And he's absolutely right. By the way, the implementation of get hashcode for string on 32-bit and 64-bit return different results. So never you'd get hashcode for sharding unless you're doing that for in-memory stuff. If you need it persistent, you want to do something like, I don't know, CRC or MD5 or those sort of things. And now we have a question. How do you add a database to existing shards? So let's look at that. We're now going to shard, now we're going to assume that we're using just two databases. Well, we're actually going to start 3. And let's see what's happened. Now I'm going to do this. This should actually be 2. Now we have just 2 items in here. And let's see what happened. Actually, in this case, all of the items went into a single shard. I'm not really sure why. I'm pretty sure this is because. But let's look at what happened when we add another shard. Now, again, we are doing this. And yeah, sorry, I also have to update this one. So now we actually have it split among all of the shards. Now you can see it in here. The interesting thing to remember is that the only time that we actually use this function is when we are actually creating this on the first time. You can see that we encode the shard ID in the metadata, and obviously we also have it in the key itself. So even though we now have here ASEAN companies, they will still continue to work. So we're able to add a new item into the system, a new server into the system, and new stuff is actually going to go into the new server, while the old stuff is actually going to be on the old server. We do not do resharding on the fly. This is a very complex operation, and it was known to actually take down systems because the load of actually doing the resharding was so big that it actually took down the production system. So that's something that we are currently not supporting. And if you want to do that, you can obviously do it yourself very easily based on your own logic. So that is how you add new servers. Now we have a question from David. If you realize that your sharding strategy is off balance, where one of two servers are getting the most, is it possible to rebalance the data with a different sharding strategy? So David, as I said, it is possible to change the sharding strategy after the fact. It works because we only use the sharding strategy on the very first time that you store a document. We don't do, and that will rebalance the new stuff. It will not modify existing stuff. You're absolutely able to do the resharding yourself at that point, but because we already encoded in the document ID, we generally don't recommend of doing that. There are many motivations to actually modify the shard function. For example, you may start by just doing basic shard by a force letter. And then you realize that there are some letters that appear much more common than other letters. Then you want to take that into account. Maybe you add a new server into the system. Something that is actually very common to do is to say something like that. We're now going to modify our sharding strategy, and something that is common to this is, okay, when we add a new shard to the system, your sharding strategy is basically going to say, okay, let's direct more of the new stuff into the new shard so it gets filled with more data and it balances out with the other stuff. The major reason why we put in, we encoded the shard ID inside the document ID relates to optimizing a very common scenario, which is this one. Because this is a very common scenario, we really thought that this deserves its own optimization. There are other alternatives of doing that. Again, everything that I'm talking about here is just conventions. There are ways for you to change that at any point in time. You can also decide at some point to say, you know what, I don't like this, I want to go with something like this. Or I want to go with, I'm going to do that and then do some modulus function or something like that. This is all up to you, but we wanted to go with the default approach being as unobtrusive as possible and as easy to get started as possible. Another thing to remember is that this also means that you can get started and change your mind at a later point in time. Because even this fact, the fact that even something like this, you can change and says, oh, this is one, but I'm saying this is starts with one, so it probably should go to this one, but oh, this value is lower than 16,000, which is where we did the cutoff to the secondary server. And again, you can inject your own logic into the process and make those decisions. But the default one was to make it absolutely obvious what was going on. So, and because we wanted to make it absolutely obvious, we went with this approach. It's easy to debug, it's easy to understand, and it's much, much simpler to work with over the long run. Anything where you cannot, when someone cannot just get it in a few minutes is going to be too complex to go to production. Let's see. Okay. So Juma is asking, can sharding be enabled at a later time as the data store goes large? No. You cannot do you cannot just flip on a switch and get sharding out of the box. Well, you could, but that would require you to do some major effort there. The easiest thing to do would just to do a one-time migration from a non-sharded store to a sharded store. That would be much simpler. Now we have a question from Chris. Can you show the sharding strategy you're currently using on this example? And the sharding strategy we're using is actually this one. And this is using the default shard resolution strategy. And this one is actually using a bunch of stuff. Mostly you can see that here we're assuming that this is the separator based on the identity part separator. If it's there, we're only taking the first part. If not, we're taking the full thing. And what else we have here? We have a bunch of stuff related to how we query that. This is the value translator. There was another one in here somewhere. Yeah, so this is the result. Then we have, this is the default, get shard ID 4. If you don't specify this one, if you don't tell us how to shard, we just use a simple round robin. Then we have something called metadata. This is for things like doing hiro and stuff like that. This is more complex. This is how we determine. Now we're going to do a request to a server. So this is for doing a query. This is how we understand if a query can be optimized. So this is not non-trivial code, but all in all, even with everything, is less than 150 lines of code. So it's absolutely something that you can grok in a few minutes and figure out and write your own. And again, we made sure that everything is as simple as possible, and you have the hooks to go in and change. And you have the hooks to go in and change at every level that you have. We have a question from Chris. If you change the shard strategy after the data has been created, how does a query work that expects the data to be sharded based on the new strategy? Chris, if you change the sharding strategy, you have to make sure to be either that old stuff can still work, and this is related to how you do it in your shard strategy, or when you change the shard strategy, come on, shard strategy was just invented to make it hard for me to pronounce. So when you change the shard strategy, you also need to actually do the resharding yourself. We rely on the shard strategy to actually tell us what to do. The default shard strategy will work because we rely on the encoding of the IDs. So that should work for most of the time. But if you have something else, then we have no way of actually handling that. We have another question from Juma. Will it affect performance if sharding is enabled later? For example, 90% is not sharded and 10% is. So, as I said, you cannot just turn on sharding at a later point of time. The shard weight, so how much of the data is located at any server is obviously important. You want to get into as balanced a set as possible. But then again, maybe you have more knowledge and say, okay, this shard is for the important customers. Instead of having 50,000 customers, have 5 customers. And this is done intentionally, so queries and operation on the important customers are going to complete faster. Okay. So before we go to questions, there is one thing that I actually want to discuss with relation to scaling RavenDB. So far, what we have talked about is assuming a homogenic data set. What do I mean by homogenic data set? I'm saying that all of my data needs to be either sharded or replications replicated as a single set. And this is actually not always true. In fact, in many cases, it's not true. Let's think, for example, about the case where we have users, and let's talk about the Stack Overflow scenario. In the Stack Overflow scenario, we have relatively small amount of users, but huge amount of questions and answers. If I was sitting down and planning on actually doing the RavenDB, the Stack Overflow RavenDB scenario, I would say that users and questions are two distinct data sets that deserve different treatments. For example, I would say that I'm going to have multiple servers. In each servers, I'm going to have multiple databases. So let's say that I'm going to start with 4 servers, and every server is going to have the database, a database called users, and that database is actually going to be replicated in a master configuration among all 4 servers. On my client side, I'm actually going to say that I'm going to do read from all servers. So whenever I'm doing a query, that query is actually going to go into one of those servers. And obviously we have the master thingy going on. So a user that exists on one of them will very rapidly exist on any of them. And that gives me that reduces the load for users, because creating a user is something that happens far less frequently than creating a question. But it also means that I have the entire set of users in all of the databases. So think about the scenario where I have a failover in one of the servers. I don't lose access to all of my users, or to some of my users, because all of the data set is still there. Now, let's talk how I'm going to handle the questions. The question scenario, we have questions, we have answers, and obviously I'm going to say that, for example, I'm going to do, there is no real meaning to sharding a question over something. So from my point of view, I can just do blind sharding on that. But I really care to do good sharding, to do data-driven sharding on the answer based on the question ID. So right now we have questions and answer being sharded among the 4 servers, and those go into a different database called questions. So on each of the servers, we actually have 2 databases. One of them called users, which is in a master replication on all of the servers, and we have questions, which is in which is just a database. It doesn't take part in a replication scenario. Now, what does this give us? It gives us the ability, because most of the load is actually on the questions, then because we have done a blind sharding, so basically round-robin sharding on the questions, the load for the questions is evenly distributed among all of the servers. The load for the users, because we have specified read from all servers, is also evenly distributed among all servers. But if we have a case and a server goes down, and then think about what's going on. We're going to lose access to some of our servers, some of our questions, but we never lose access to any of the users. From the point of view of the Stack Overflow user at that point, what we will have is actually, okay, we don't see some questions. You probably won't even notice that, but you aren't actually impacting the user in a way that they care about, or we have a server going down, some of the user can't log in. stuff like that, being able to have different different scaling behavior for different data sets is very important, and considerations like that. Oh, I need to remember, I need to consider how to do sharding replication, and I need to make sure that if a server goes down, I have the minimum amount of interruption. Make treating the replication and sharding scenario is one size fits all, something that you have to be really careful about. You really want to pay attention to what is the meaning of the actual dataset that you're using and how you're actually using that. Okay, so this is all the material that I have so far. This is the time for asking questions. So go ahead. Any questions? Ooh, that was fast. Okay, so we have a question from Chris. In lieu of reshard, can you force a query to ignore the shard strategy and query all of the shards to have the data assembled on the client? Chris, you can absolutely do that by providing your own shard strategy. So the shard strategy is the one that is actually decide on which shards the query is going to run. And by basically telling the shard strategy that basically modifying the shard strategy, you can tell it, oh, I want to run the query on all the servers. Unrelated to sharded. If I want the ETAG value of my document to be included in my models, so in this case you want to explicitly expose the ETAG. Yeah, Chris, what you actually need to do is to create an iDocument conversion listener, and that way you can actually do the round trip. This is where you can say, okay, this is the ETAG. I'm going to shove it into the into my entity and vice versa. Okay, so it seems that we have no further questions. Guys, thank you so much for showing up. I hope that you had fun, and this is it. Bye-bye.